Hello everybody, this is Mr. Bowman. Today we're going to be looking at an introduction to transformations. So what a transformation is when you take a graph and you move it around on the graph itself. So we usually try and do a single thing, so either move it up or down, left or right, make it expanded or contracted. There's a couple things we can do. And today we're only going to look at two, and they are known as rigid transformations, which means that the shape is not going to change, it's just going to change its location. So we're going to start with a vertical stretch, okay, or shrink, depending on if it's getting bigger or smaller. So to know what we need to look at here and have this conversation, we need to make sure that we know where we're starting. So these are called parent functions. And the one we're going to primarily deal with is the parent function for something called a parabola. So the parent function for a parabola is y equals x squared, or f of x equals x squared for using function notation. And what a parent function is you're going to have an equation with nothing done to it. So it's as simple as you can get it. So there's no extra addition, subtraction, multiplications, anything like that in here. So this is a symbol of a parabola, which looks like a U as we can get. So it's usually something shaped kind of like that. So our standard one looks like this. So our parent function one. So for both of our examples today, we are going to be starting with that base function. So let's go ahead and get these on there so we don't have to worry about them later. Okay, so both of these are x squareds, or y equals x squareds, however you want to write it. Okay, all right, so the first one is a vertical, is you're going to add something outside of the x squared. So what I mean by that is maybe we'll have y equals x squared plus 2, or y equals x squared minus 4, or something like that. Okay. So that just means we're going to take every point and move it up or down that amount. So if it's plus 2, I'm going to move each point up 2. So this one's going to fall off. But this one I'll move up 1, 2. This one 1, 2, 1, 2, 1, 2, 1, 2, and this one would also disappear. So when I connect these together, the entire graph is the exact same shape, just shifted up 2. Okay. Or this one, which I'm going to do in green. Probably should have wrote it in green, but there we are. This one is negative, so I'm going to be going down instead of up. So I'm going to take each of my original red points and go down 4. So 1, 2, 3, 4. 1, 2, 3, 4. It doesn't matter which points you start with. So if you want to start here, you want to start whatever. So just each one of the major points. 1, 2, 3, 4. 4. Okay. And then I'll do the same on this side. Yep. 1, 2, 3, 4. And then when I connect these ones together, be the same graph, but shifted down a little bit. So it's the red one just moved down my graph. Okay. So we're going to do the same idea over here, but instead of a vertical stretch, I'm going to be using a horizontal shift. And I realize I did use the wrong word here. This is not a stretch. This is a vertical shift. My apologies. We'll talk more about stretches later. All right, so we're going to do the same idea here, but with a horizontal shift. When you add and subtract, it's still adding and subtracting, but it's not outside. It's going to be before you square it, so it'll look like this. Okay, we're going to add and subtract to the x before we square it. It'll be, quote, inside our function. Or we could likewise subtract just as easily. Okay. Now here you have to be careful. Whereas these ones made sense, if we add, we go up. If we subtract, we go down. These are actually backwards. Okay. So if you're adding 3, you're not going right 3, you're actually going left 3. Okay, so it's a little weird. So you have to be careful to make sure that you keep those straight. So I'm going to take each of my points just like I did, but instead of going up and down, I'm going to go right and left. So in this case, it's left 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So I have the exact same graph, but shifted left. So the entire, basically just took the red one and slid it to the left. All right, so looking at this one now. This one, since it's still horizontal, it'll be backwards, so it looks negative, so it seems left, but it's actually right. So we're going to take all the red ones and go right 1. So take this, go right 1, right 1, right 1, right 1, right 1, right 1, and right 1. So right now we're just looking about learning how to shift these things around. So whether we're going up and down, left and right, maybe a little bit of both. Theoretically, you could have something that's in both of them. You might have one that's y equals x plus 1 squared minus 3. So if you do this, you'll have 2 steps. So you will have this one, which is, remember, backwards because it's inside. So that'll be left 1, then down 3. So you would do that all in one go. You go left 1, down 3, left 1, down 3, left 1, down 3. So it's possible you may even see ones like this. So you're just going to be putting these together and playing around and see what you get.